Hi everyone. Today I'll be presenting my talk called Portraying the Patterns, Tools and Strategies for Effective and Compelling Visualization of Research Data. So in today's presentation, we're going to have 5 sections. We're going to have a quick introduction just to let you know who I am. We're going to talk about 3 key aspects of presenting data. So the tools of the trade, like what we have available to us, the design of the data. So how does it that we actually make sense of what we have in our research, and the presentation of the points. So we can see how the data we've got implies something or comes to some sort of a conclusion. At the end, we're just going to recap the main points of what we talked about today. Okay, so just a quick introduction to myself. My name is Mark McCormack. I'm currently in the final year of my PhD studies. My studies are on the collaborative use of generative AI technologies like ChatGPT in higher education. So basically, how can we use ChatGPT in a collaborative way to help us learn? My background is in computer science and software engineering, so I'm very familiar with working with data and programming in that aspect. But I won't go all too in-depth into programming today. We'll keep it nice and high level so that we can take stuff away from it. And just for a bit of context, my research areas are in generative AI for education, large language models, and collaborative education technologies. Now, before we get started with the tools of trade, I always like to give an example of why data visualization is so important. So I have a graph here. This is a graph that was made several years ago. And what it does is it depicts the soldiers during one of the Napoleonic Wars when they went to Russia. So it seems like a very odd graph at the start, but it's a very creative way to illustrate a point. So you can see that there is a line at the top in beige, and there's a line at the bottom in black. So the width of each of these lines represents how many members were in Napoleon's army at a time. And the further across to the right they go, the further into Russia they go. As you can see, it starts out somewhere in France, they go to Moscow, and then the black line represents the journey back. So the creative thing here is that the data, while we could just have it as a number saying it started with this many soldiers and ended with this many soldiers, the graph here, or the data visualization, tells a story in some sense. So we can see the journey that they had across the way to Moscow and then on the way back. And through that, we can see how many soldiers were lost along the way. There's lots of creative ways we can visualize data, and it's important to do so because it can be more captivating to an audience maybe than just a set of numbers or a simple bar chart. But I think it's important that we start with the basics to get an idea of how we can build up to something like this. But this is just an example of something that could be done with data visualization once we've learned the tools of the trade. So let me just go back to the slide now. Okay, so regarding the tools of the trade, the question here really is, what software should we use when we're presenting results? There's lots of options out there for lots of different things, and we need to know what one works best for us. Now, this has been kind of simplified in late years. Most researchers tend to use a programming language called Python for their analysis and presentation of data. The nice thing about Python is it's one of the easiest programming languages to learn, and you don't have to know a whole lot of it to get a lot out of it. So there are plenty of resources online on YouTube to guide you in the research for this, and there's tutorials specifically for presenting some data. I'll show you an example of this. But the key thing to remember here is that Python is usually going to be the tool you're using to present your data. Now, Python on its own is fantastic, it's great, but it also has some extra tools that we can make use of. The 2 main ones are matplotlib and SPUR. So matplotlib is a tool that helps you to plot data into different types of styles. So these can be things like bar charts, pie graphs, whatever you might like, even histograms. The good thing is that it combines directly with Python, and you can present the data in several different ways. Again, I always like to give examples of what this might look like. So on the matplotlib website here, you can see that there's several examples of how you might go about plotting data. So for example, if we wanted to make a bar chart, you can see it provides a little guide on how you might go about making a bar chart, where you have your data here. This is a tool that integrates directly with Python, so you won't have to add anything extra other than matplotlib itself. The other one we spoke about before was SPUR, and SPUR is essentially the exact same thing, except it looks a little bit different. At the end of the day, this just comes down to what's your preference when you're displaying data. So SPUR's graphs are some examples here, are a little bit more colorful, a little bit more extravagant. It all depends on what kind of data you're working with. If you're working with something that's a bit simpler and easy to plot, maybe using a tool like matplotlib would be best for this. But if you want something that maybe catches someone's eye, or the data needs to be represented in a more complex way, then SPUR is a good tool as well. The nice thing about SPUR as well is that it also integrates directly with Python. So you can just copy this directly into a Python file and be able to see what your data looks like in this fashion. It's very useful, and it's very nice to be able to just bring it in quite simply. Now, if you're working with maybe some more tricky data, or you really need some specific statistics stuff, there's another tool that's an alternative to Python called RStudio. It's a bit of an older language, but it's very, very good if you're working on something that's maybe very maths heavy. So if you're working in fields that need stuff like statistical significance or really, really specific things in statistics, then I would suggest RStudio. If you already have the data and you just need to display it, then Python is the way to go. Now, to give an example of how easy Python is to work with, I've got my friend ChatGPT to write me a little script. I do my research with this tool, so it was fitting to get it to help me with this, but I have to double check the code to make sure it works. So we're not going to go through this line by line. It's not a programming lesson today, but to give you an idea of how one would maybe present their data with Python, there's really just 5 steps to it. The first step is to import the tools that we might need. So at the top here, you can see I'm bringing in the matplotlib library, like we spoke about earlier. And I'm bringing in something else called CSV, which just lets me work with maybe something like a spreadsheet. Maybe all my data is there. The second step is I just need to make 2 lists to hold all of my data. So this one is going to hold all of my X coordinates, and this one is going to hold all of my Y coordinates. So by combining these 2, we're able to make an XY graph, something like a Cartesian plot. This step here, without going into all the values of it, just looks into the data that we have in our Excel spreadsheet and saves all the data in that spreadsheet into those lists so we can use it later on. The last bit here just says we want to make a plot that uses the values from X and Y. It should be this big, should have that title, these labels, and then the last step is just to show it. Now, I'm not expecting anyone to remember all this or to have learned this off, but just knowing that there is an easy step-by-step process for how you can translate your data from something like a spreadsheet into a visualization using something like Python. So you have the 5 steps where you bring in your tools, have your lists to keep the data, bring in the data, make your graph, and then show it. So those are the tools of trade: Python, Matplotlib, SPUR, RStudio. These slides will be available to you afterwards if you want to go back and look at them and test it out yourself. Now, the most important part, I think, of the conversation today is the design of the data. So how should we design the graph to visually stand out? This is very important. So when we're designing charts, there's a couple of key principles that should guide us. The data should be easy to understand, and the visuals should be pleasant and accessible. When you're choosing how your chart should look, you should use colors that are complementary to one another, convey meaning clearly, and are accessible to individuals with color vision deficiencies. So if anyone's colorblind, then it should be accessible to them as well. Tools like colors.co can help you build these, so they help you find colors that would work well for it. And while visual design might seem secondary and maybe not so important, well-designed charts attract attention and encourage viewers to engage with your data. In contrast, cluttered or visually jarring charts can be really easily ignored. As you can see on the right-hand side, the left graph is a lot nicer to look at. The colors work well with each other. It's not too cluttered. Everything's labeled, makes sense. Whereas the graph on the right-hand side, it doesn't look so good. It's very contrast heavy, hard to read. So making use of, you should also make use of intuitive visual cues to enhance clarity. So for example, green often implies that something is positive. Red often suggests that something is bad or negative. And icons like a plus or minus sign can usually integrate growth, improvement, or negative. So by using these familiar icons or these familiar colors that we have in our head, you might be even able to convey things a lot easier in the graph. For example, on the good graph here in the visual image, you can see that the green is to do with profit. So profit is a positive thing. We associate that with green. If we had another line maybe to do with loss, we could make that red. So it's easier to understand without needing to go in detail. Now, When you're designing a graph, you should also ask yourself, would someone understand this without me explaining it to them? This is especially important for posters, which are often viewed without the researcher there. If your graph isn't immediately clear, your findings might be overlooked. If you have to spend more than a couple of seconds trying to understand it, they might just skip it. So to improve the clarity, try to avoid clutter and focus on only the essential information. If you have many data points, consider whether there's a simpler, more visual way to present them. So on the right-hand side here, we can see that we did a test where students' test scores was correlated with their time of study. And while on the right, we can see, yes, they're all the students and all the multicolor lines, it's very cluttered. So maybe the best thing to do here is to average it out, as we can see on the left. And that makes it a lot more understandable. As well as that on the left, you can see that your labels and axes are clearly identified and precise, so we can instantly understand what's going on here. We can see that there's a test score here and an hour studied. So it's very easy to understand what's going on in this graph. And finally, include a brief one-line sentence or caption beneath the graph. This should highlight what the results indicate and not serve as a full explanation, but just a quick takeaway for the viewer. So for this graph, it just says the test scores increase steadily as study time increases. So even if they don't understand the graph, there's one sentence there that describes everything perfectly. Now, the final thing, the presentation of the points. So the final points here are relevant solely for presenting your data in conferences or poster sessions, but nonetheless, these are key in helping the audience to understand the data. If you're writing a poster, you should always keep the dimensions in mind, as you want the data or graph to be understandable from 3 feet away, so that if there's a crowd around your poster, they can understand what's on the data without having to squint at it. For posters, you should always choose to use something that scales well. So I'm sure a lot of you have seen images that when they're printed on larger pages, they don't look so well. These are usually JPEGs or PNG images. So when you're presenting your data, always try to save it as an SVG file or to save it into a PDF. Both of these will scale well, and make sure that no matter what size you might be printing your poster at for a session, it's understandable. The final thing is, if you're presenting data with PowerPoint, feel free to make use of the tools that are present in it. One of the best tools for this is the morph transition, which can help you zoom in and out of key pieces of information. We actually seen this a little bit earlier. We had this piece of code here, and what we did was we zoomed into a little bit using the morph transition. You could just as easily do this with a graph to highlight different pieces, and given you have the tool there for it, it's always best to do this. It'll help you to highlight things without having to confuse your audience. Other than that, that's everything to do with the presentation. I might recommend those resources again that I said. So we have the Python language, which is going to help you present your data. There's Matplotlib and Seaborn, which helps you to show it in a nice, appealing way. There's RStudio, which is for more mathematical data if you're working with statistics. We mentioned Coolors earlier on, which is a website that helps you to make good colors together, so get colors to match so that they don't look jarring next to each other. And then finally, looking up stuff online about different cool types of data visualizations. There's lots of different types here that you can have a look at. People present data in different and creative ways, and it's always a good way to have a look and see what way you might display your data, because maybe there's a better way than just a bar chart on its own. Perhaps it's something using a circle graph, perhaps it's something using sort of waves like here, or maybe it's a little bit more creative like we've seen at the beginning. And yeah, that's all for my presentation. Thank you.